Now, in the past we were attempting to calculate the area between two values underneath the standard normal distribution. Now we're going to try to deal with it when we have an actual area and we're trying to find the z-value that breaks up that threshold or makes a threshold in between values. Now, in the first instance, we're going to look for the area to the left of the z-value to be 0.95. So 95% is below in this greenish area, and the white area here is the remaining 5%. So the z-value is going to separate the top 5% from the bottom 95%, and it's also noted as the 95th percentile. As if you recall the definition of that, the percentile is the percent that you're above. So whenever we're dealing with this, we're going to look at the area below. We use the normal CDF function in the calculator to determine the area between two. We're going to use the inverse norm function, the one right below it in the calculator, when we're given an area. So seconds and vars giving us a distribution. Number 3 is the inverse norm. So the inverse norm is when all we have is an area and we're looking for a z-value. Now how this works is we have to give it the area to the left. The area to the left of the z-value. In this case, 0.95. And again, the total area under the curve is going to be 1. So even if it's 95%, you must convert that to a decimal. So 0.95. So that area, or that z-value, excuse me, is 1.64, about 1.645 is a key number that we're going to use. So 1.645 is that value. That separates the bottom 95% and the top 5%. Another example, say we want the middle 95%. So we take the bottom 2.5% and the top 2.5%. So now instead of going 0.95, we've got a couple options. We can find this one here at 0.025, so second vars inverse norm, 0.025 gives us a value about 1.96. So that value is negative 1.96. Now, we can do the same thing. We can take the inverse norm of, this is 0.025, this is 0.95, so 0.975. Or we can take a look at it, and knowing that the normal distribution is symmetrical, this value with 2.5% on the tail is going to be the same as this one, only this one will be positive. So one z-score is negative, the other is positive. Our other option would be to take the inverse norm of 0.975 and we would get that value as well.